one of the biggest problem with the institutionalized structures and the organizations on our planet is that the tendencies for people to continue to think in the same line of thoughts of their predecessor and the people before them, and so eventually it always leads to the same conclusion, and so it's very hard for them to break through that and actually come up with new ideas that may seem quite radical at the beginning, but may have great value.
Nassim, the Renaissance Project, tell me about this.
The Resonance Project.
Resonance.
Yes, like ringing bells. The Resonance Project is an organization I founded, a nonprofit organization that brings physicists together and scientists from all walks of life, biologists and mathematicians and so on, and we work on unified theories, on furthering unified theories and developing new understanding and bringing them to the public, as well as, you know, working on applications to these theories to further our world, because, you know, these theories are very interesting and they have great philosophical meaning. I mean, for instance, the idea that you're made of. I mean, think about it, George. Imagine that you start experiencing as yourself as these little mini black holes vortex of the space. Yeah. And you know, because you're made out of billions of these little vortexes. And imagine that you're exchanging information with the vacuum and that, you know, the vacuum is exchanging information back with you by feeding you your reality, which now you interpret and feed back to the vacuum and so on. Well, imagine that you understand the dynamics of this. Really, the root of consciousness becomes available to you. You can actually become a vacuum engineer. I mean, literally, in your own consciousness, in your own feedback, you can start to alter that feedback. Well, there's applications to that in advanced technology and understanding of the laws of nature as well. So, you know, the Resonance Project is part of, you know, developing ideas in engineering for future technologies that could transform our world. If the vacuum has all this energy in it, and if the vacuum is actually coherent in some region that makes up our material world, then there is nothing that stops us from actually making the vacuum a little coherent here or a little coherent there to extract extremely large amount of energy or curve space-time or even warp space-time and travel the universe.
Let's take this break, Nassim, and we'll be right back with more on Coast to Coast AM. Let's talk a little bit more about the unification theory, which you've worked on so much in your career. Are there different unification theories, Nassim, or primarily just one?
No, there's multiple unification theory out there right now. Most of them are incomplete. They don't necessarily do the job. They, in some cases, get very close, and in many cases are very, very complex. And so what I'm excited about with this new paper I just published is that it's very simple, and it clarifies the issue very, very rapidly, and it doesn't demand, you know, hundreds of extra dimensions or, you know, some strange strings or anything like that. It actually is very fundamental. It's very based on fundamental mechanics and fundamental physics, and it unifies the fields very nicely.
Now, you talk in your DVD series, Crossing the Event Horizon, about 4 forces of nature that are effectively unified. Let's go through those 4 forces. What are they?
So currently there is a gravitational force and an electromagnetic force. right? And there is a strong force at the atomic level and the weak force at the atomic level. And basically what my theory does is that it eliminates the strong force and the weak force and reduces the forces to only two forces, a force that pulls in, gravitation, and a force that pulls out, electromagnetic fields. And it starts to establish this relationship between the two in terms of a feedback so that, you know, we get this information network that I was describing. And this feedback, you know, this feedback is based on this topology of a torus, which is like a donut. If you can imagine rolling a donut onto itself, like going from the edge of a donut, and if you could roll it towards the middle, towards the hole, then, you know, you would have the bottom part of the donut rolling out and the inner part of the donut rolling in, so that you can have expansion and contraction at the same time. So that our universe would be like that, for instance. Instead of the universe just expanding, it would expand and contract at the same time. But because we are very, very small in it, and we can only see a very small portion of it, we see the expansion side because we're most likely in that section of the universe. But at the same time, at the poles of the universe, then there would be stuff going back in. We see that dynamic even at the galactic level, and we see it in the plasma dynamics of our sun. We see it all over the place. So this unification theory actually unifies the fields by basically getting rid of two of the forces of the quantum world and replacing them with the forces that were described by Einstein's field equation.
Does string theory fit into any of this?
String theory is a theory that was produced in some ways to avoid singularity, to avoid this point of infinite density that produces the difficulty in terms of Einstein's equation and in terms of describing the atomic level. In my case, I do the exact contrary. I actually allow the singularity to exist. I allow the nuclei of an atom to become a black hole, because remember, from my first thoughts when I was a kid was that the center of an atom could get divided and divided and divided to infinity. And actually, you know, we've built accelerators that are larger and larger and larger to break the atom in smaller and smaller and smaller bits. I mean, we're breaking bits like millions and millions of times smaller than the atom now, and every time we have to build larger and larger accelerators. I mean, the one we just built is 17 mile long. It costs some $12 billion to build, and, you know, we're looking for bits that are millions and millions of times smaller than the atom. And my theory says, well, you can always get smaller bits. You can always build a larger accelerator and get smaller and smaller parts. It's not telling you much about the universe. What we should pay attention about is how does the bits get produced? What is the pattern of division? Because the pattern of division from infinitely big to infinitely small would be the key to the structure of space-time, the key to creation. And that's more important than trying to find some God particle that would be the smallest thing the universe does. And then eventually a physicist would write a new equation saying, oh, actually, we could probably divide that into a smaller bit. And so, you know, this is changing this whole view to saying we have infinities, we have mini black holes, and we call them atoms. And then if we treat the atom that way, then all of the mass starts to come out to give the right results for the measured values we get in laboratory.
You talked about the God particle, which is what they're going to be looking for when they finally turn on that particle accelerator at CERN, not too far from where you were born, I think. What happens? Could they create a black hole there, Nassim?
Yeah, the math shows that they would have the energy levels that they could create what they call virtual mini black holes. But, in contrast to what I'm saying, first of all, I don't think there's any reason for alarm there because, in my view, everything is already mini black hole.
No need to head for the hills. There's no place to run anyway.
That's right. That's right. But I think that they're going to have surprise. I think they're going to get some really interesting data, and that some of this data is going to confirm a lot of the things I'm predicting.